is number 1, okay, resistor only. That is see the behavior of inductor, capacitor and resistor will change based on DC and AC. Okay, when DC comes, capacitor will not allow current to pass. Okay, inductor will be very happy. It will become short circuit. Short circuit means it will be just like a wire. It will allow. Capacitor will not allow. Okay, resistor, okay, just like a normal. But when AC comes, the behavior of inductor as well as capacitor will change. Clear? Okay, just like based on the teachers or based on the friends, our behavior will change now. Same way, inductor, capacitor, resistor will behave differently when DC comes and when AC comes. Okay, so what we will do is, we will put resistor alone in the AC circuit. We will analyze its behavior. We will do that for resistor alone this much, for capacitor alone too much, for inductor alone that much. Then when mixing, what will happen? Mixing is the easiest thing. For mixing we will apply our trump card, phasor we will throw, we will finish it very fast. Okay, this will not trouble you at all. AC will not trouble you at all any cost. Okay, provided you catch every concept clearly. So we will start with the resistor, inductor, capacitor, then we will apply phasors and we will mix it. So the thing is, resistor, source. When AC source is there, okay, just like a worm, it will come. For DC, what will happen? Plus and minus, this thing will come, right? So for AC, pulu. So R, this E is equal to E naught sine omega t. E is equal to E naught sine omega t. Then what will happen? Current will pass through this. Current will pass through this. What will be the value of current? This is going to be E naught sine omega t divided by R. Okay, so this is going to be what? I naught sine omega t. That's it. So sine omega t E naught by R sine omega t, and this is nothing but I naught sine omega t. Clear? Simply draw the waveform of this. If we draw the waveform of this, E is equal to E naught sine omega t. So this is going to be the E naught, okay, theta or omega t or t. Okay, clear? This is how it comes. What happened to I? I also will follow the same pattern, but here amplitude alone is changed. Amplitude alone is changed. Since we have divided with R, we will take a small amplitude, chinna kutti amplitude, cute, chellamana amplitude. So this is going to be I naught. This is going to be minus I naught. Here this guy is E naught sine omega t. This dotted line is nothing but I naught sine omega t. Okay, clear? So if we draw a phasor, if this is V, this length, if we consider this as V, this chota length, cute length, we can consider as what? I naught. So this is V naught and I naught. Okay, based on the angle it will rotate. We can say that when we put a resistor the current across the resistor and the voltage across the resistor both are in same phase. They are in same phase. Okay, so E same phase. This voltage is what dropped here. This source voltage will be dropped there. Okay, if it is delivering, so what to eat. Okay, otherwise things will not work out. Okay, correct? No. So E naught sin omega t is the voltage. Resistance is also what? I naught sin omega t. Only that magnitude E naught and I naught is different. Sin omega t is same. So first thing, the very important thing which we need to take from here is E and I will be in phase. Okay, clear? Right. Suppose instantaneous value, just like this. If we take instantaneous value, then this will be what? V, and same will be what? I. Only amplitude will be different. Remaining things are same. See, this is the value of E. So here corresponding value of I naught we will be getting. Clear? Now we will change. We will add inductor only. We will change this into inductor. Okay. This is L inductor. So the voltage E, this one, plus VL is equal to what? 0. Correct or what? Whatever voltage it gives will be delivered where? Will be delivered in the inductor. Correct or what? So E plus VL is equal to 0. Now what is the voltage across the inductor? You are repeating, no? Already in electromagnetic induction we have not covered this. Remember, the voltage across the inductor VL is what? L di by dt. L di by dt. So di is equal to, so if we put here E is equal to minus VL and E is equal to minus of L. This is what? Minus, no? This is also minus. Pi is equal to minus of di, L di by dt will come. Lenz's law, we negative will come there. Clear? If you do not know, just that the voltage across the inductor will be minus L di by dt. Okay, right. So minus L into minus of di by dt. So we could say that E is equal to L di by dt. Clear? Now if I write di, I will be getting di is equal to 1 by L E dt. Correct or what? Small value of current, okay, for small duration will be nothing but di is equal to 1 by L E dt. So for full current value, if I need to understand what is this current I, this is nothing but integral 1 by L E dt. Okay, so taking this 1 by L outside, that is constant, no? I will be getting E dt. Now if I substitute 1 by L integral E naught sin omega t dt. I am not going to do for value. I am not going to do for cycle. To some instant only I am going to find. Instantaneous value of current is what we are. No. This is instantaneous value of source voltage. So R is equal to I naught sin omega we found for resistor. Sin omega we trying to find. So we are not going to put. This is going to be indefinite integral. Integral when we do we'll be getting a constant, right? That is what. So this is going to be 1 by L. E naught is constant. When you differentiate we will be getting cos omega t. Cos omega t plus constant we will be getting. Correct or what? Divide by omega. Okay, divide by omega. Correct. Okay, so E naught by omega L will be taken. I am sorry, this is negative, will not come. Cos omega t. Okay, integration of sin omega t is just cos omega t. Oh, minus is there. Okay, minus is there. Right. So minus, check. This minus should go. Let's see. Okay, fine. E naught by omega L. This will become minus cos omega t plus c. Okay. Okay. So here constant I have written, but this source doesn't. When source doesn't have any constant, technically the current also will not have any constant. I am not supplying any DC value here, so this one will not have any DC value. For that case I can consider the constant as 0. Okay, source doesn't have any constant, so definitely this will not have any constant. So I is equal to minus E naught by omega L cos omega t. Okay, regarding that okay, it will go right. Okay, so one second. So what will happen now? The source is E naught sin omega t. Source is E naught sin omega t. There is a negative here, and this is in the form of cos also. Now what we need to do, if we convert this into sine, then we will be able to say current is leading or lagging. Okay, so when we convert this, I will become E naught by omega L, and this is going to be sin omega t minus pi by 2. Okay, clear or what? So this cos omega t will be leading. Now this negative also will go, and this will become sin omega t minus pi by 2. Clear? Done. Completed. All these things for your understanding, you need remember this all. Okay, the thing which we need is, I am removing this. So when I write all these, this is going to be helpful somewhere, but here the crux of the discussion what we have is the following, that is, when the source is E is equal to E naught sin omega t, I am getting the current I is equal to E naught by omega L sin omega t minus pi by 2. Means in inductor current lags voltage by pi by 2. That's it, over, done. Okay, easy. Now children, when E is equal to E naught sin omega t, I was what? E naught by R sin omega t. So whatever comes here in the denominator, that is objection of that passive element against current. Just like a resistance, this inductor is also objective. This is called inductive reactance. Inductive reactance, we can say I is equal to E naught by XL sine omega t minus pi by 2. Sine omega t minus pi by 2. When we draw the waveform, if we draw the waveform, how it is going to come? This is E naught sine omega t. This is E is equal to E naught sine omega t. This guy is late, so we can start from here. No, we can start from here. So this is how it is going to be. Now if we extend, it will start from here. So this is going to be I is equal to I naught sine omega t. This is nothing but E naught sine omega t. If we draw the phasor diagram, suppose if this is I, this is going to be E. Okay, either we can put E is in this direction. If we are putting E in this direction, then I will be in this direction. Okay, phase difference of 90 degree, current should be lagging. Clear or what? Okay, and inductive reactance XL is equal to omega L. So XL is what? Omega L is 2 pi f into L. 2 pi f into L. 2 pi f into L. So if I put frequency and inductive reactance, then inductive reactance is directly proportional to frequency, a straight line. Direct proportion means straight line. Clear or what? Okay children, so we will solve the handout, some questions in the handout. Then again we will go back to circuit theory. We will see the capacitor alone in the circuit. Okay, like that. So see the first question. The electric mains in the house are marked as 220 volt 50 hertz. Okay, what is the peak voltage and RMS voltage? So what is this actually? This is VRMS. So one question is over, done. What is peak voltage? V naught is what? Root 2 into VRMS. So this is going to be root 2 into 220. So this is somewhere around 311 volt. Done. Okay, we will see fundamentals, then we will slowly increase the complexity. Second question. An electric bulb operates. Okay, done. Over. Okay, over. Okay, I will be moving fast. So wherever you have trouble, what you should do? உங்களுக்கு வெக்கம் தானே சார் நல்லா கூப்பிட்றதுக்கு, அப்படி இல்லையா? வெக்கம் இருக்குமே, கொஞ்சம் பேருக்கு இருக்குன்னு தான் சொன்னாங்க. ஸோ அவங்க என்ன செஞ்சால் போதும்? இப்படி காமிச்சா போதும். ஓகே, இப்படி காமிச்சிங்கன்னா ஐ வில் ஸ்லோ டவுன். ஓகே, சொல்லவே வேண்டாம், ஜஸ்ட் ஒரு இண்டிகேஷன். இப்படி. ஓகே, டன். Second question. An electric bulb operates at 12 volt DC. 12 volt DC. So 12 volt DC. 12 volt DC. Electric bulb operates at 12 volt DC, right? If this bulb is connected to an AC source and gives normal brightness. So normal brightness means same brightness. Then what would be the peak value of the source? What would be the peak value of the source? If DC is giving, what is RMS value? RMS value is the DC equivalent of AC. So we can take this as what? ERMS, right? Then what they are asking, what is the peak value? So peak value is nothing but E peak is equal to root 2 ERMS. So root 2 into 12. So how much will come? Somewhere around 17 will come, right? Done. Okay, fine. Third question. The peak value of an alternating voltage applied to a 50 ohm resistor is 10 volt. Okay, V naught is equal to 10 volt. Find the RMS current. So IRMS is actually ERMS divided by R. Okay, and this is peak value. This is peak value E naught. Okay, so if the voltage frequency, okay, right, find the RMS current. So first we need to find ERMS. ERMS is E naught by root 2. So this is nothing but 12 by root 2. 10 volt. Okay. Okay, so fine. Thank you. So 10 by root 2. Enna varudhu? So this is ERMS. Namakku vendadu IRMS. So IRMS is nothing but ERMS divided by the resistance. So 10 by root 2, and the resistance is here what? 50 ohm. Correct? Okay, so 50 root 2. Correct or what? Okay, so if we solve this, what we will be getting? Theta, tappa. Incorrect. So what is the answer? 141.4 milliampere. Is it correct? Correct. 141 milliampere. Okay, so this can be done in this way also. I naught is equal to E naught by R. E naught is 10 divided by 50. Then you can come to IRMS. Anyway, whatever method. Another parallel to that, another question here it is, if the voltage frequency is 100 hertz, if the voltage frequency is 100 hertz, okay, that is F is equal to 100 hertz. Okay, if F is equal to 100 hertz, then what is the, write the equation for instantaneous current. So I is equal to I naught sine omega t. So I naught we have 141.4 milliampere into sine 2 pi f. So this is going to be 200 pi t. Correct or what? ತಪ್ಪು ಇರುಕಾ ಹಿಂಗೆ ಆಚೆ? One point. I naught is 1 by 5. I naught is. Sir, this is I naught. Oh, okay, fine. Okay, right. Okay, so 0.2 layer. Okay, right. Okay, so this is 0.2 amperes. Okay, 0.2 amperes. Otherwise 200 sine 200 pi t milliamperes. Okay, clear? Okay, shall we do the next problem? Any doubt? Anyone? Okay. Calculate the RMS value of alternating current shown in the figure. Calculate the RMS value of alternating current shown in the figure. Okay. So number 4. Okay. So this is the signal 2 ampere I T. Yes. 2 ampere. Okay, so here see IRMS, if we take, it is root of square of average. So here I1 square, I2 square, I3 square, if we take I1 square plus I2 square plus I3 square, if we take, okay, average of this is I1 square plus I2 square plus I3 square divided by 3. Okay, because this is constant value. Okay, substituting, we will be getting 2 square plus 2 square plus 2 square divided by 3. Correct or what? Okay, so this is how much? 12 by 3 root 4 we will be getting 2 ampere. Okay, so sinusoidal signals I naught by root 2. For other things you need, if it is given in the form of figure, you can do like this. Okay, another question also will come, we will deal that. Okay, clear? Okay, fine. Fifth question. The electric current in a circuit is given by I is equal to I naught into T by tau. Okay, for some time, I mean instantaneous value. Calculate the RMS value for the period T is equal to 0 to T is equal to tau. Okay, so we need to find the RMS value. IRMS T is equal to 0 to T is equal to tau. Okay, so again same thing, this is a function, this is not constant values like this is a function of time. So what we do, first root mean square, first thing is we will take square, so I naught square T by tau the whole square. Okay, fine. Next thing is mean, so taking the average of this, what we will do, 0 to tau. Okay, I naught square T square by tau square. Okay, and D the time interval which is tau. Okay, understood the method? Same basics whatever we have followed till now. Okay, right. So if we do this, what will happen? I naught square by tau square is constant, T is there, so T cube by 3 integrating 0 to tau, this tau, so tau cube. Okay, so I naught cube I naught square by tau cube into tau cube by 3, correct or what? Okay, so this tau cube will be cancelled off. Finally the RMS value IRMS is equal to what? I naught square by I naught by root 3. Clear or what? Now I is equal to I naught into T by tau. I is equal to I naught into T by tau. Do you feel anything about this equation? What kind of equation is this? Whether it is circle or straight line or a parabola or whatever it may be. Ellipsa. Straight line, right? Straight line. That is straight line. So straight line போயிட்டு கீழ வந்து மறுபடியும் straight line கீழ வருது எது? Sawtooth. Just look at that answer. Look at the answer. IRMS of sawtooth already we have written. அது suppose this is T, this is I. The straight line equation is y is equal to mx. C intercept illa y is equal to mx வந்து I, x வந்து T. Okay, now I naught by tau is constant. Appadi. So that will be the slope. I naught by tau will be the slope. Clear or what? Idu thane? This is the IRMS, right? For sawtooth. Okay, so y is equal to mx. If you see, then you should understand. So max konjam therinjina, thevayana alavukku therinjina, things will be easy. Right. So this is this relation, sawtooth, straight line, IRMS derivation, all these things make us remember this well. Marakame. Okay, don't forget. Don't waste time solving too much. Okay. Next question. Question number 6. If the effective value of current in 50 hertz AC circuit is 5 ampere. Effective value means itself. Effective value is nothing but RMS itself. Okay. So effective value in 50 hertz is given as 5 ampere. Okay, 6. IRMS is equal to 5. What is the peak value of current? Just to teach you that effective, what is effective value? This question is, nothing else is there much. So I naught is equal to root 2 into 5, root 2, 1.414 into 5. The answer is 7.07. Okay, 7.07 ampere. Okay, right? So this is first session. Second question in that is mean value of current over half cycle. Mean value of current over half cycle. What is the answer? Mean value over half cycle. RMS value is 7.07. Okay, RMS value is 7.07. 50 hertz AC is given. Okay, so this half cycle I average is what? 2 I naught by pi. 2 I naught by pi. So directly put that. Etra gutta Shabiri? 2 I naught by pi. So 2 into 7.07 divided by 22 by 7 into I naught is okay, sorry. Okay, fine, that's it. How much you will get? 4.5 ampere. Okay, calculation part take care. Okay, next is what? The value of current in 1 by 300 seconds. The value of current in 1 by 300 seconds. So T is equal to 1 by 300 seconds. They are asking instantaneous value. Instantaneous value. So I is equal to I naught sine omega t. I is equal to I naught sine omega t. Alright. So I is equal to I naught is 4. I'm sorry. I naught is 0.07 sine 2 pi. 50 is given. So 50 into time is 1 by 300. Bus. Okay, done. So 7.07 sine in terms of what will come? Okay, so here we'll have to solve now. Okay, 100 pi by 300. Pi by 3 sine 60. 7.07 into root 3 by 2. Done. So based on the option, don't waste time in calculating. Most of the time it will be given as I naught root 3 by 2 I naught, right? Option. Okay. Next problem is the instantaneous value of voltage in volts is given by the expression E is equal to 140 sine 300t. What is the peak value? So this is nothing but peak value. Now what is RMS value? ERMS is equal to 140 by root 2. Then what is the frequency of supply? So this is nothing but omega t is equal to 300. So 2 pi f into t is equal to 300 into t. So t cancel. Then f is equal to what? 300 divided by 2 pi. But okay. Okay, next question is a resistance of 40 ohm is connected to an AC source of 220 volt 50 hertz. 220 volt is RMS value. 50 hertz is the frequency. Find the RMS current. Okay, find the RMS current. So question number 8. Resistance is given as 40 ohm. ERMS is given as 220 volt. Question is IRMS. So IRMS is ERMS by R. So 220 divided by 40. Okay. So this is going to be 4.5. Correct or what? 4.5 ampere. Then the maximum instantaneous current in the resistor 5.5 ampere. Next question is the maximum instantaneous value, maximum instantaneous current in the resistor, nothing but instantaneous IRMS into root 2. How much it will come? 7.8 ampere. Right. Now in this one question is the time taken by the current to change from its RMS value to maximum value. Okay. This is completed so far. Okay. All are comfortable? All of you? Perfect? No worries, right? No manavali? Okay. Manavali and Solomon. Manavali is our word within the class. Okay. அப்படிலாம் சில இருக்குது ஸ்டூடெண்ட்ஸை கையில் எடுக்கிறதுக்கு நீங்கள் கொஞ்சம் if you agree then only I can take classes no. ஸோ அதுக்காக உங்களை சந்தோஷமாக வைக்கிறதுக்காக lot of things are there. Let's see whether it will work out. Right, children? So in this question, this is a good question. Okay, third part is a good question. Okay, time taken by the current to change from its RMS value to the maximum value. Say for example, okay, now if this is the current, okay, definitely we know that this is going to be I naught. IRMS is what? I naught by root 2. இதுக்காக நம்ம ஒரு நம்பர் சொன்னீங்கல்ல, இது கரெக்ட் தானே? ஓகே. ஸோ 0.707 கிட்டத்தட்ட இங்கே வரும் 0.707 I naught. That is in. So from here the signal to become here, how much time is taken? Okay, easy. The instantaneous value of this, instantaneous time of this, if we find out, things will be done. Oh, I is equal to I naught sin omega t. So first we will find the time instant of maximum value of current. Okay, so what we do, this side, this is also I naught, instantaneous value I naught ஆகிறதுக்கு எந்த டைம்ல this will become I naught. So remaining free, everything is okay. So we will substitute all that, then we will, okay, so I naught will get cancelled off. I naught will get cancelled off. We know that sin omega t is equal to 1. So from this we will understand that omega t is equal to omega t should be what? 90 degree, pi by 2. Omega t must be pi by 2. So this is going to be 2 pi into 50 into t is equal to pi by 2. Correct or what? Okay. Unnecessary messages எல்லாம் வரும்ல வாட்ஸ்அப்பில் நமக்கிட்ட இரிட்டேட்டிங்காக செய்கிற மாதிரி ஃப்ரெண்ட்ஸ் கிட்ட இருந்து அவங்ககிட்ட இருந்தெல்லாம் வரும்ல, ஜஸ்ட் நெகட்டிவ். அப்போ நம்ம என்ன பண்ணணும், அதை அப்படியே அமுக்கி பிடிச்சிட்டு மேலே ஒரு பெட்டி இருக்குல்ல, அதில் போட்டுக்கினா ஒரு மனசு சந்தோஷம் தானே. மோஸ்ட் எக்ஸைட்டட் திங் என்னென்னா, இது கேன்சல் ஆக போகும்போது how happiness we feel, no, it's so exciting. So அதே மாதிரி we will do. Okay, so this is going to be 100 t is equal to what? 1 by 2. So t is equal to 1 by 200. 1 by 200. So let time instant as 2. Okay, so this is going to be T2. Okay, இதே மாதிரி தானே IRMS கண்டுபிடிக்கலாம். Okay, so what we do, IRMS is nothing but I0 by root 2, correct? IRMS is I0 by root 2 is equal to I0 sin 2 pi f T1. Okay, over. Okay, so 1 by root 2 வரதுக்கு இது என்ன ஆகணும்? 1 by root 2 வரதுக்கு this must be what? Pi by 4. So 2 pi f T1 is equal to what? Pi by 4. Okay, this one, what is this 100? So 100 now 50. So this is going to be 1 by 400. 1 by 400. Done. So T1 and T2 we got. So how much duration it takes? So this duration is what we need. இது கொண்டெல்லாம் ஆன்சர் வரல. Duration we need to understand. So time duration we need to get T2 minus T1 or difference of these two. That's it. Okay, so 1 by 400, 1 by 200 minus 1 by 400. So this is 0.5. Okay, என்ன பண்ணலாம்? 1 by 10 raised to 2 வெளியே எடுத்தீங்கன்னா this is going to be 0. வேண்டாம். 1 by 2 minus 1 by 4. So அரையிலிருந்து கால் எடுத்தா எவ்வளோ? அரையிலிருந்து கால் எடுத்தா கால். Okay, so this is going to be 1 by 4 இல்லைனா என்ன 1 by 4 into 10 raised to 2. 0.25 into 10 raised to minus 2. So based on the option millisecond or second you can choose. So this is going to be how much? 2.5 millisecond. Correct or what? 2.5 millisecond. Okay, keep it there. Now we'll come back. Till question number 8 we have completed. Now we'll come back to circuit theory. Okay, over. புரிஞ்சுதுங்களா? ஏதாச்சும் கிளாஸில் உட்காராம தெரியுமோ? ஓகே, okay, clear, done. Any doubts so far? Clear, no? Everything right? Okay, right. So study in the class itself. Study in the class itself. All the formula, basics, fundamentals, everything. Study in the class itself. Evening, after going back home, just make the things stronger. That's it. இது நீ படிக்கிறதுக்காக இன்னொரு நாள் டைம் டேபிள் வந்து இன்னைக்கு ஏசி கிளாஸ். ஓகே, வெள்ளி ஞாயிற்றுக்கிழமை இது படிக்கிறதுக்காக ஒரு நாள். நோ டைம் ஃபார் தட். இங்கேயே முடிச்சிடுங்க. டன், ஓவர். Okay, those who know, revision and done. Okay, just if you want you can do good questions. That's it. Right, next one is capacitor only. So third one, capacitor. What we are doing here? Okay, what we are doing here? Okay, பாத்தீங்கன்னா ஒரு girl Jayashree is with friends, very bold, bombastic. ஓகே, ஆனால் தனியாக இருக்கும்போது ரொம்ப பயம். அப்போ ஜெயஸ்ரீயை கரெக்டாக அனலைஸ் பண்ணுறதுக்கு என்ன பண்ணணும்? ஜெயஸ்ரீ ஷுட் பி அலோன், தென் வி ஷுட் டெஸ்ட், தென் வி வில் அண்டர்ஸ்டாண்ட் ஹவு போல்ட் ஜெயஸ்ரீ இஸ். சும்மா ஒரு பேர், நமக்கு பிடிச்ச ஸ்டூடெண்ட்ஸோட பேர், அவ்வளோதான். சேம் வே பாலா தனியாக போடும்போது ஹவு பாலா இஸ் பிஹேவிங், அல்லனா பாலா இப்படி வரும். ஓகே, வெரி ஸ்ட்ராங். தனியாக இருக்கும்போது பாலா இப்படி அப்படி பயம்தான். ஸோ லைக் வைஸ் inductor alone, what is the behavior? Capacitor alone, what is the behavior? Resistor alone, what is the behavior? Okay, individually, right? So now this is capacitor. Worm pulu E is equal to E naught sin omega t and C. Okay, now let us see. Current is passing. Okay, now what is current? Current is equal to dq by dt. Okay, q is equal to cv ன்னு பார்த்திருக்கல, q Q is equal to CV. So I is equal to d by dt of C into source, correct? C வந்து constant, so if you take outside, this will become d by dt of this source is nothing but E naught sin omega t. Okay, so when you differentiate, this omega will come out, omega c, and this is going to be how much? E naught cos omega t. Correct or what? C omega E naught cos omega t. So this is in terms of omega, and now cos I is equal to E naught by R sin omega t when R was there. Same way I is equal to E naught by XL sin omega t minus pi by 2 when L was there. நீ இந்த நம்பரையும் அதே மாதிரி போடணும்ல. We should not make fightings with 100 kg person, 25 kg person. No, we should not do that. We should have a comparison, right? So same way, now we will convert this into what? Sine. So E naught, so this objection, everything we are putting in the denominator, 1 by omega c. This is going to be sine omega t plus pi by 2 bus. Okay, so we can understand that when capacitor alone is there, current will be leading the voltage by pi by 2. Okay, and this one, just like R XL, we got this as E naught by XC, which is called capacitive reactance. Done? Okay, so I is equal to XC sin omega t plus pi by 2. Okay, when capacitor alone is there. Done? Okay, can I erase the circuit? So what will happen if E is equal to E naught sin omega t? Then current will be leading. Current will be leading means if this is pi by 2, current will be leading by pi by 2 means it will start from here. It will start from here and it will be going like this. Okay, so okay, start pi by 2 early, or pi by 2 early it will reach maximum. Okay, clear? Suppose if we try to draw the phasor diagram, what will come? Current will be leading. No need of this. Okay, suppose if this is voltage, this will be current. Okay, then XC, inductive capacitive reactance. Capacitive reactance is nothing but 1 by omega c, or we could say 1 by 2 pi fc. Okay, so here XC is inversely proportional to the frequency. Inversely proportional to frequency. Inversely proportional means always what? Something is inversely proportional. Suppose if this is XC and this is F, inversely proportional means what? Hyperbola. Okay, this is going to be like this. Okay, okay, so hereafter, so basics are ready. Now you need to remember certain things. Whenever we get these situations, apply that. Okay, first thing is IPL and CCL. IPL, Indian Premier League. Hereafter, IPL means inductor potential leads. Correct? Always, எப்போமே inductor மட்டும் இருந்துச்சுன்னா potential leads. Potential leads whom? Potential leads current. போட்டி கரண்ட்டுக்குள்ளே வோல்டேஜ்க்குள்ளே தான். கரெக்ட்? CCL, Celebrity Cricket League. இன்னிலிருந்து capacitor current leads. Okay, IPL, inductor potential leads, capacitor current leads. Okay, remember that. ini. Now onwards, mix of things will come. Capacitor can come, inductor, everything can come. Whose inductive reactance or capacitive reactance, whose reactance is better, who has more reactance, its effect will be more. So even though everything is there and we are able to calculate what, phi, phase difference, if inductive reactance is more, it is sure that that phi will be the lead for voltage. If it is capacitive reactance is more and we are able to find phi, then we can understand that that phi will be lead for current. Okay, how to find what? Phi, impedance, everything we will see now. Okay, now see. Okay, suppose this is XC ohm, because this reactance will decide the phase in the sense voltage will be leading or lagging, will be decided by whom? XC, XL, R. Okay, same way this could be XL. Okay, same way this is R. So R will be in phase with the source, which will be in phase with the current, and on this will not make any problem with the phase. XL, XC, they are opponents. Okay, clear. Now because of this R is there, XL is there, XC is there. These two guys will be always opposing. So avangalukulla போட்டி நடந்ததுக்கு அப்புறம் அதான் முடிவாகும். Okay, after the clash between these two titans, we will be able to decide the net obstruction, which is called impedance or Z. Okay, I told you everything we will deal like vectors, everything we will deal with vectors. So what we do is, impedance is nothing but this is equal to R square plus XL difference XC the whole square. Whichever is more, its effect will be more. Okay, so R square plus XL minus XC or XC minus XL the whole square. Clear? This is the impedance. Okay, right. So this is about impedance. Now suppose R is like this. After calculating the reactance reactance due to capacitance and reactance due to inductance, we got a net reactance. Whether this be this side or this side doesn't matter. Okay, so this is what is the impedance. If bala is a vector, without changing the direction and magnitude of bala, I can keep it here now. Okay, without changing the direction. So same way, okay, kept it here. Then this is what is phi. So we can say that tan phi is equal to net reactance divided by resistance. So this is imbu chalama kubudula imbu phi. So phi is nothing but tan inverse of x net divided by r. So over what you suppose x net is given, resistance is given. So suppose sometimes reactance is not given, instead of that resistance is also there, impedance is also there. Should we waste time for finding reactance? இப்படி படிச்சிருக்குல்ல, tan inverse of reactance by resistance படிச்சிருக்குது. So from impedance we will find the reactance, then we will find phi. Is it அப்படி தேவையா? தேவை இருக்கா? Suppose impedance is given, we are strong with vectors, no? So we are strong with the basics. What we can do? We will do cos phi. Cos phi, yeah. Cos phi is equal to what? R by Z. Okay, so phi is equal to cos inverse R by Z. Done, over. Okay, so it depends on the situation. We can play. Reactance is given, tan. Impedance is given, cos. Sin போட்டுட்டு தொலாவிட்டு இருக்க வேண்டாம். Okay, sin போட்டுட்டு என்ன கண்டுபிடிக்கலாம்? Sin போட்டுட்டு suppose if these things are there, reactance is also given, impedance is also given, then based on the question you can do. அவ்வளோ அந்த அளவுக்குலாம் கேட்கல, அந்த அளவுக்கு கூட they don't ask, but if they ask, right? So phi is equal to sin inverse of net reactance divided by what? Impedance. Anything, okay, based on the available data we can play. Okay, okay, then இப்போ we know how to find impedance. நமக்கு தெரியும் அல்ல முகேஷ்? How to find impedance we know how to find the phase difference. இனிப்போ என்ன வேணும் கரண்ட் கண்டுபிடிக்கிறதுக்கு? எதுவுமே தேவையில்லை. Over. Done. Okay, so suppose if current is asked, what we need to do? E naught by Z. E naught by Z. இங்க sin omega t தானே எப்பவுமே. Z can be found from this formula. Phi can be found from any of this formula. போதும். Over. So based on this, if we want, we can write in this way: E naught by root of R square plus XL minus XC the whole square sin omega t plus tan inverse of X divided by R. Done. Over. Done. So just I am summarizing. Fourth one, let us take inductance and resistance, source L R. This is going to be XL and this is going to be R. So current I. So I is equal to, this is going to be E naught sin omega t. So this is going to be E naught divided by what? Root of R square plus XL square sin omega t plus what? Phi. So phi is nothing but, suppose if this is XL and this is R and this is going to be the Z. So suppose this is phi, this is going to be XL, Correct? So based on that we can write tan inverse of XL by XR. So based on whatever we want we can do. Cos inverse of this one by cos inverse of what? Cos inverse of R by Z. Lena sin inverse of XL by Z. Anything we want we can write. Correct? So here what will happen? Current will be this 5 வந்து இது நெகட்டிவ் ஆயிருக்குமா பாசிட்டிவ் ஆயிருக்குமா? You need not play with the trigonometry and struggle. Just think and tell me. This 5 will be positive or negative? Minus. என்ன இருக்கும்? ஈஸி, ரொம்ப ஈஸி. அவ்வளோதானா சே இப்படி எல்லாம் கொஸ்டின் கேட்கக்கூடாதுங்க சார்னு சொல்லுவாங்க. Whether it is negative or positive. Okay, Jayashree. Papa, what's your name? Swastika. Swastika, I used to ask some doubts sometimes. Need to be very careful. Okay, so here inductor IPL inductor potential leads, potential lags na maga panni hoga kudadu. Inductor potential leads, inga capacitor irukka, so inductor potential leads, so inga current enna agum, lag. So always 5 will be negative without any doubt. Correct dane? Okay, done. Avlodha. Okay, so inga phases and all very easy for you. Phases and all very easy for you. Suppose, see, based on this inductor and resistance value, phase will be something. So what will happen? Suppose if this is V, where should I draw current? Inge dane keela inga pi by 2 dane inga pi by 2 5 edach onnu. Okay, we will have to find out. Correct or what? So fifth one, right? So capacitance, resistance inga pulu. Okay, R C X E. What will happen? E is equal to E naught sin omega t. So I is equal to E naught divided by root of what? R square plus XC the whole square, and this is going to be sin omega t plus phi. In phi plus or minus? Okay. In the phi enna iruppa? Plus or minus? Doubt irukappa? Capacitor current leads, so definitely this phi will be positive. Clear? Over. So inga voltage irukumbodhu current inga thane varano. I should draw current here only na inga. Okay. Okay, so last what? LCR circuit. Okay, so E is equal to E naught sin omega t XL R XC. So I is equal to E naught divided by root of R square plus XL minus XC the whole square sin omega t plus phi. So and the phi வந்து plus or minus? Depends. Inductance அதிகமாக இருந்தா minus, capacitance அதிகமாக இருந்துச்சுன்னா plus. Capacitance இல்ல, capacitive reactance. Okay, which reactance, they based on that we can do. Correct or what? Clear? Okay, so an inductor an inductor and resistance are connected in series, okay, to a source of 12 volt supply with a 50 hertz frequency, okay, and a current of 0.5 ampere is flowing, okay. So current differs in phase from applied voltage by pi by 3. So current differs voltage in phase by pi by 3, okay, pi by 3. So what is the value of resistance? What is the value of resistance? So I'll give you 2 to 3 minutes. Try this. Tell me the answer. Direct questions allame you will do. Direct questions you will do definitely. So konjam, okay, light small. Any answer? சொல்லுங்க சொல்லுங்க மக்களே. என்ன நான் சொல்லிட்டு இருக்கிற எல்லாமே ஆன்சர் வருதில்லை, என்னாச்சு? മുകേഷ് മോൻ ഇത് കിട്ടി? என்ன ஆன்சர் கிடைச்சது? போட்டுருக்கு. போதும், உங்க மேல இருந்த என்னோட நம்பிக்கை என்னாச்சு? என்ன சொல்லணும்? So here இது யார்? இவர் யார்? வோல்டேஜா? இது IRMS. ஓகே, ഈ കുട്ടി இந்த குழந்தை வந்து ഇൻസ്റ്റന്റോ നല്ല ഹെഡിയൊന്നുണ്ടല്ലോ, ഇൻസ്റ്റന്റ് ആണോ? അത് 5 ആംപിയർ ഇൻസ്റ്റന്റ് കിട്ടുമോ? AC സോഴ്സ് ഉണ്ട്. 5 ആംപിയർனு சொல்லும்போது இன்ஸ்டன்ட் சொல்ல முடியுமா? AC source இல்லைங்களா? Okay, this is AC source, so this cannot be instantaneous or peak value. I told you, if they have given something, that is always what? RMS. So this is IRMS, this is ERMS. So Z is equal ERMS by IRMS. So ரொம்ப ஈஸி தானே? So this is what, children? 12 divided by 0.5. This is going to be 24. Okay. So okay, what they are asking, this I differs V in the face of pi by 3. What? Pi by 3, correct? No, this is R and this is. So what we can do, this is adjacent side and this is hypotenuse. So cos phi is equal to what? R is how much? We need to calculate, divide by. Z is how much? 24. So this is nothing but cos pi by 3 into R by 24. Okay, correct. So from this we can find it out. R is cos, this part is this cos 60. Cos 60 means 1 by 2. Okay.
Reverse by pi by 3 എന്ന് വെച്ചാൽ ഇനീഷ്യലി തന്നെ pi by 3 ഫേസ് ഉണ്ട്.
അങ്ങനെയൊന്നും ചിന്തിക്കണ്ട. ഇനീഷ്യൽ ആണെങ്കിലും ഇനീഷ്യലി തന്നെ അത്
ഇതിൻ്റെ ഇപ്പോൾ pi by 2 ഓൾറെഡി ഇതിൻ്റെ വോൾട്ടേജും കറണ്ട്
അതുണ്ടാവും. അല്ലല്ല, അതായത് ഈ ഫൈ എന്ന് പറയുന്നത് എല്ലാ സമയത്തുമുള്ള കറണ്ടും വോൾട്ടേജും തമ്മിലുള്ള ഫേസ് ഡിഫറൻസാണ്. നമ്മൾ സത്യം പറഞ്ഞു കഴിഞ്ഞാൽ ആ ഫോർമുലയിൽ I is equal to E0 by Z sin omega t plus phi, അതിൻ്റെ ഡെറിവേഷനും നമ്മൾ കണ്ടിട്ടില്ലല്ലോ. അത് എക്സ് സി ഫോർമുലയിൽ ഡയറക്റ്റ് തന്നിട്ടുള്ള റിലേഷനാണ്. ഈ ഫൈ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വേറൊന്നുമല്ല, കറണ്ടും വോൾട്ടേജും തമ്മിലുള്ള ഡിഫറൻസാണ്. ഇതേ ഫൈ തന്നെയാണ് റെസിസ്റ്റൻസിൻ്റെയും ഇമ്പിഡൻസിൻ്റെ ഇടയിലുള്ള ആംഗിളും.
ഓൾറെഡി
ഉണ്ട്, ആ പൈ ബൈ 2 ഉണ്ടായിരുന്നു. പക്ഷേ XL by R ചെയ്യുമ്പോൾ അത് പിന്നെ പൈ ബൈ 2 നിന്ന് മാറി പൈ ബൈ 2 പ്ലസ്സോ പൈ ബൈ 2 മൈനസ് ഒക്കെ ആയിട്ട് ഒരു കോൺസ്റ്റന്റ് ഫേസിലേക്ക് വരും. അതാ. സോ ആ പൈ ബൈ 2ൻ്റെ ഇതും കൂടി ചേർക്കേണ്ടതില്ല. That will take care of by that formula. We need not worry. Okay, so children, here the thing is, when inductor and resistance is there, there is going to be a phase difference. Since inductor alone is there, that voltage will be leading. By how much? Some phi. That phi we can find by using either this method or any other method. Okay, whichever is available. So here the angle between resistance and impedance, that is also fortunately same angle. So using trigonometry we can derive all these, but whatever answer we are going to get with the same method. Okay, so inductor means pi by 2, lead is there for voltage, but when resistance also comes, resistance will take some part of current, some part of voltage, so it will change the phase. Kudo korakyo, I mean it may be add, it may subtract, that we need not worry. Simple, direct.
ആദ്യം ഇവർ കൊടുത്തിരിക്കുന്നത് ഫേസ് ബൈ പൈ ബൈ 3 എന്നല്ല. അപ്പോൾ I0 എഴുതുമ്പോൾ I is equal to E0 sin omega t പ്ലസ് ഒരു പൈ ബൈ 3 ഇവിടെ എഴുതിയിട്ട് പിന്നെ
ഇല്ല മൈനസ്
പ്ലസ് പൈ ബൈ 3 പ്ലസ് പൈ ബൈ 3 പിന്നെ ഇതിൽ ഡിറൈവ് ചെയ്യുമ്പോൾ ഇവിടെ ഒരു പ്ലസ് പൈ ബൈ 3 മൈനസ് ഒരു പൈ ബൈ 2 കൂടെ വരും. അപ്പോൾ ചെയ്യുമ്പോൾ പൈ ബൈ 6 ആവില്ല. അപ്പോൾ പൈൻ്റെ വാല്യൂ പൈ ബൈ 6 ആവില്ല.
ഇല്ലില്ല, അങ്ങനെ
ഓൾറെഡി ഇവിടെ ഇനീഷ്യൽ ഫേസ് ഇല്ലല്ലോ. നമ്മൾ ഡിറൈവ് ചെയ്യുമ്പോൾ I0 സൈൻ ഒമേഗ ടി എന്ന് പറയുമ്പോൾ അവിടെ ഇനീഷ്യൽ ഫേസ് ഒന്നുമില്ലല്ലോ. ഇനീഷ്യൽ ഫേസ്
ഈക്കില്ല, ഐ പിന്നെ ഉണ്ടാവുന്നതാണല്ലോ. ഐ പിന്നെ ക്രിയേറ്റ് ആകുന്നതാണ്.
അപ്പോൾ ക്രിയേറ്റ് ആകുമ്പോഴാണ് മൈനസ് പൈ ബൈ 2 വരുന്നത്.
ക്രിയേറ്റ് ആകുമ്പോൾ
മൈനസ് പൈ ബൈ 2. ഇവിടെ ആദ്യം ഒരു പൈ ബൈ 3 കറണ്ട് തമ്മിലുള്ളപ്പോൾ അപ്പോൾ പൈ ബൈ 2 മൈനസ് പൈ ബൈ 3.
ഇത് ആദ്യമുള്ള ഇനീഷ്യൽ ഫേസ് അതൊന്നും പറയുന്നില്ല. ഇനീഷ്യൽ ഫേസ് എന്ന് പറയുന്നില്ല. ഇവിടെ പറയുന്നത് എന്താ വെച്ചാൽ ഇൻഡക്ടറും റെസിസ്റ്റൻസും കൂടി വന്നാൽ ഇവർ തമ്മിലുള്ള ഫേസ് ഡിഫറൻസ് π/3 ആണെന്ന് മാത്രമേ പറയുന്നുള്ളൂ. നമ്മൾ പിന്നെ വേറെ ഒന്നും നോക്കേണ്ടതില്ല. ഈ π/2 പിന്നെ ഉണ്ടാകുന്ന ഫേസും എല്ലാം കൂടി ചേർത്തിട്ടുള്ളതാണ് ഫേസ് ഡിഫറൻസ്. ഇല്ല, ഇൻഡക്ടർ മാത്രം വരുമ്പോൾ സി ദ ഫേസ് ഡിഫറൻസ് ബിറ്റ്വീൻ കറണ്ട് ആൻഡ് വോൾട്ടേജ് ഈസ് π/2 when only inductor is there. Resistance, when resistance comes, it will change. When only capacitor is there, capacitor current will be leading voltage by π/2. When resistance also comes, it is some pi, but that is going to be what? Lead. Current leads. The other case, voltage leads. That is the only thing. Katya. Chumma. Okay, done. Right, children. So now we will go to okay, done. Another question. 10 no inductor. Okay. Okay, see, this is 100 volt, 100 volt, okay, 100 volt, 50 hertz, 100 volt, 50 hertz. Resistance is given as 10 ohm, okay, so, and the phase angle between current and voltage is π/4. What is the value of L? കറണ്ട് മിസ്സായിരുന്നില്ല ക്വസ്റ്റ്യനിലിருந்து.
R is equal to omega L and that formula use பண்ணி போடுங்க.
இந்த ஃபார்முலா வேணாலும் போட்டுக்கலாம், நோ வரிஸ், உங்கள் விருப்பம் தான். அல்டிமேட்லி வி ஷுட் கெட் ஆன்சர். ஓகே, ஐ திங்க் திஸ் இஸ் கரெக்ட். வில் see. Okay, so here tan phi is equal to what? XL divided by R. Okay, so tan phi is tan π/4 is equal to, see how this is, if this is R, this is XL, and if this is, we will take this one here, phi, that is why tan phi is equal to XL by R. So tan π/4 or 2 pi f into L divided by R. L we don't have, so tan π/4 all up 1. So R divided by 2 pi f is equal to L, which is nothing but 10 divided by 2 into pi into frequency 100. Correct or what? 150 50. Yes, done. Over. So this is going to be 10 by 100 pi. So this can be cancelled off. So 1 by is on the answer. You can options you can mark. Clear or what? Okay, done. Okay, now let us get into L and R, LC, everything overlay. Last one is LCR. You called me? Anyone called? Okay, so last one is L, C, R, R, C, L, E is equal to E naught sin omega t. This can be I. So here I is equal to what? E naught divided by Z. So Z is going to be R square plus XL minus XC the whole square. Okay, right or what? Now sin omega t plus phi. Okay, so this is the value of current in this case, LCR circuit. Whichever is major, okay, based on the value of XL, if the inductive reactance is more, whatever phi we are finding out, that will be leading. Who will be leading? Potential will be leading. If capacitive reactance is more, current will be leading. Okay, because V is equal to what? I into XC or I into XL. So based on the inductive and capacitive reactance, what will happen? The voltage will be different. Correct or what? Now in this formula, suppose in case XL is going to be XC, when XL is going to be XC, what will happen? I is going to be E naught divided by R, E naught divided by R and sin omega t, because completely what will happen? Suppose if we try to find phi is equal to what? Tan inverse of this term will become 0, right? So every effect of these reactances will be gone. So this condition is called what? Resonance. This is what is resonance. So this condition is what is, okay, so resonance means XL is what? Omega L and XC is omega C. So 1 by L, correct or what? So omega is equal to LC we can write. So from this what we can write is F is equal to, okay, 2 pi F is equal to 1 by root LC, and finally F is going to be 1 by 2 pi into root LC. Okay, so this is called resonant frequency. Resonance frequency, angular resonant frequency. Okay, so clear? So we will discuss about resonance after a break.
Is the XL square minus XC square or the whole square?
XL here, what was the impedance previously we said? This is R square plus XL square we used to do, right? So this is going to be XL square minus XL minus XC the whole square. Yeah, that one. Clear or what? Done. So continuing the resonant frequency. So resonant frequency will come when the inductive reactance is equal to capacitive reactance. Since both are opposing each other, reactance value will become 0. So there will be effect of only, there will be effect of only resistance. Okay, so suppose if you draw a graph, okay, suppose if this is I, okay, and if this is frequency, frequency. So what will happen? Tuning of radios is application of this one. Then if you walk along certain paths, metal detector in the airports, all these work based on the resonant frequency. So in tuning of radios we can change the capacitor values. So capacitor values we will change in such a way that finally what will happen, this XC will become XL, because this is 1 by omega C and this is going to be omega L. Just by changing the value of capacitor, at one point this will become equal. So the advantage is like, so previously, suppose if you consider IRMS, this was what? ERMS by Z. ERMS by Z. I naught is equal to E naught by Z. So Z means along with R, who is also coming? Reactance was also coming. So the overall objection will be more or what? Okay. So when this reactance talavali is gone, what only will be there? Resistance only will be there. XL is equal to XC means IRMS will become ERMS divided by R. Okay. So resonance, only certain frequencies are resonant frequencies, right? So the value of current will be less actually. Value of current will be less, but value of current will increase towards the resonant frequency, and at the resonant frequency, we will have Z is equal to only R, and we are going to have very quality current. Quality current means quality signal. My dear FM, புரியுதுங்களா? அது வரைக்கும் எப்படி நல்லா இருக்குங்களா? புரியுதுங்களா? ஸோ இது வரைக்கும் இங்கே வரும்போது வேர் இங்கேனா சம்வேர் லைக் இங்கே யார் வராங்க? கடவுளா? IRMS, correct? IRMS is equal to I naught by root 2. Once after crosses this, what will happen? Page வர ஆரம்பிக்கும். Okay, everything will be clear. Signal will be very clear. Will go. Correct or what? So that is the application of this. Take it. Sherinsha, நீங்களா ஷெரின்ஷா? ஓகே, I met your dad on the way. ஷெரின்ஷா எப்படி இருக்குன்னு கேட்டாங்க. சும்மா நான் சொன்னேன். ஓகே, okay children, see, so this point is actually I naught. Maximum value of current is I naught. So here the voltage is E naught by R, not Z. So if this is F1 and if this is F2, between F1 and F2 the signal is very clear. Between F1 and F2 the signal is very clear. So we can write this as 2 pi F1 also, no? Okay, omega 1, and this is nothing but omega 2 is equal to 2 pi F2. Okay, so this width is called bandwidth. Okay, so this width, so where Z is equal to R, so this width is called bandwidth, we can say. Okay. So bandwidth is nothing but omega 2 minus omega 1. Clear? Omega 2 minus omega 1. Suppose if we consider this is delta omega and this one as delta omega, means if this is omega 1, this is omega 2, see this is FR, resonant frequency. So எல்லாம் இங்க mix பண்ணி எழுதுறதுக்கு I will write it neatly. So this is resonance frequency F0, this is F1, this is F2, okay, and this is omega 1 or resonant angular frequency omega 0, and this is omega 2. This is actually delta omega, that is the difference between this frequency and resonant frequency, and this one is again another delta omega, and this total is called the bandwidth. So either we can say omega 2 minus omega 1 is full minus idu, means this thane, okay, so omega 2 minus omega 1 or 2 delta omega. So delta omega is nothing but resonant frequency minus omega 1 or omega 2 difference resonant frequency. Clear? Okay, see pa, here there is something quality factor. So this quality factor is nothing but a measure of quality of this signals, measure of quality of this signals, that's it. A 1.5 page derivation is there in NCERT, okay. Many steps will not be there, okay, we need to sit and see, so we don't need it, okay, that derivation. Only I will give those formulae so that you can study, and if the question comes, just apply that carefully, that is enough. So quality factor Q is equal to 1 by omega R into, not LC, CR. Okay, this is one formula, okay. So omega R CR, see omega C, 1 by omega C is the capacitive reactance, so the same way this comes like that, okay. So normally in the same formula, if we need to add inductor, if we need to put inductor, what will come? மேல என்ன வரும்? Omega R into L by R, that's it, okay. Okay, then resonant frequency divided by bandwidth, resonant frequency divided by bandwidth. Resonant frequency is also frequency, bandwidth is also what? Frequency. So we can write in this way, omega R divided by omega 2 minus omega 1. Is there anything wrong if we write in this way also, FR by F2 minus F1? If we take that 2 pi outside, that will get cancelled off. Means that peak frequency, that resonant frequency divided by the bandwidth. Okay, so how much smaller the bandwidth is, how much smaller the bandwidth is, that much sharper the quality factor is. Clear? Okay, one more thing is 1 by R into root L by C. So remember for quality factor. Okay, so LCR circuit, okay, so resonant frequency FR is equal to 800 hertz. Resonant frequency FR is equal to 800 hertz. Just look at the unit and decide whether it is normal frequency or angular frequency. Okay, if it is radians, then this is going to be angular. Then don't mix again 2 pi with that. That's it. Then Im by root 2 is observed at okay, Im by root 2 is observed at frequencies, okay, 745 and 855 hertz. 855 hertz. Find the quality factor.
R by 18 land.
അതാ മറ്റേനകത്ത് NCERT-യിൽ കിടക്കുന്ന ഒരു ഫോർമുല ഡിഫറൻസ് ഞാൻ ഒന്ന് നോക്കിയിട്ട് പറയാം. മാറ്റണമെന്നുണ്ടെങ്കിൽ മാറ്റാം. Okay, right, how much you got? Okay, 800 divided by 855 minus 745. So how much will come? 800 divided by 110, right? So whatever you get from this, okay, quality factor done, over, done. Okay, then we will do some more questions, right, from that handout. Completed till question number 8. Now question number 9. What will be the readings in voltmeter and ammeter of the circuit? What will be the readings in voltmeter and ammeter of the circuit? First you tell me what will be the voltmeter reading? 90. Zero. What will be the voltmeter reading, children? Zero. Why? Because XL and XC, they are same. മനസ്സിലായോ? പുരിയുന്നുങ്ങളാ? XL and XC are same. So the voltage in that will be of opposite phase, different phase, exactly opposite phase. Correct or what? So there itself we can understand that voltmeter reading will be 0. Now just look at the ammeter reading. So I is going to be ERMS divided by Z, okay, sine omega t plus phi. This is the thing. So here XL and XC nothing is there. Okay, what is there? Only resistance is available. So ERMS, okay, what is the source voltage? 90 volt is given. So IRMS is equal to ERMS, I'm sorry, this is going to be E naught. Okay, so ERMS by Z, that is the value of the reading of ammeter will be what? RMS value. Ammeter, hot wire ammeter. The meaning is hot wire ammeter, just you add that point there. Normal ammeter means it is going to be 0, but you can take it as hot wire ammeter. Okay, just mark there, hot wire ammeter. So this is going to be, if it is hot wire ammeter, okay, this is going to be IRMS itself. So ERMS by Z. So whatever they have given there, that is what? 90 volt is what? ERMS. 90 volt is ERMS obviously, and this is going to be divided by what? 45. So this is going to be 2 ampere. And if it is general DC ammeter, answer will be 0. So you can add there hot wire ammeter. Run. Fine. Next question. An inductor with net inductance, a net inductive reactance what is given? Inductor value is given, and inductor capacitor. Inductive capacitive reactance, that's it. Inductive capacitive reactance means nothing, net reactance. So net reactance is 10 root 11 ohm. Okay, inductor capacitor reactance means net reactance, okay, is 10 root 11 ohm, and 50 ohm resistance are connected in series with the 120 volts 60 hertz supply. Okay, so the innate of this one is 10 root 11 ohm, and resistance is given as 50 ohm. So this is connected like this. Okay, so the source is nothing but 120 volt 60 hertz supply, and current is moving like this. So I'll calculate the current value through the circuit. Can you tell me? Application of whatever we have studied till now. Those who just came in the afternoon, are you finding it difficult? Able to understand? Okay, answer. 2 ampere. 2 ampere. Okay. So you found that RMS value. Okay. Right. So based on this circuit, I is equal to what? E naught by Z sine omega t plus phi. So Z is root of 50 square, that is R square plus X square. So this is going to be root of 50 square plus 10 root 11 the whole square. So this is going to be 2500 plus this is 100 into 11, correct? So this is going to be 3600, right? Correct or what? So 60 ohm is the impedance. What about phi? Phi is equal to tan inverse of x 10 root 11 divided by 50. Correct or what? So correct. So this is going to be how much? 5, right? Is equal to E naught by Z. So E naught is divided by 60 sine omega t plus tan inverse of root 11 divided by 5. Done. So this is the instantaneous value of current. Correct or what? Everything is clear, right? Instantaneous value of current. Oh, okay. So this here root 2 will have to put, right? Correct or what? No, by root 2. 120 by root 2. Is it correct now? E0. Sorry. Is this correct now? Is it correct? 120 root 2 by 60. Is it correct? So this is the complete equation. So here this will come. So I is equal to 2 root 2 sine omega t plus tan inverse root 11 by 5. Done. Over. So suppose if the value of current R is asked, that is nothing but RMS value. Okay, that only will be there in the option also. So this is I naught by root 2. Obviously this is going to be 2 root 2 divided by root 2. So 2 ampere. Okay. Done. Next question. Question number 11. Resistor of 12 ohm and capacitor of reactance 14 ohm and pure inductor of XL inductance pure inductor of inductive reactance is what is given. Okay, XL is equal to 30 ohm are given in are joined in series and placed across a 200 volt 50 hertz AC supply. Okay, so what is the current? Phase angle between current and voltage. Okay, right. So question number 11. Question number 11. Okay, resistance, then capacitive reactance, then inductive reactance. They are all connected in series and they are connected not DC, AC. Okay, and this is going to be 200 volt 50 hertz AC supply. So here this is going to be 12 ohm. Capacitive reactance is how much? 14 ohm. Inductive reactance is 30 ohm, right? 30 ohm. So these are the data given. So what will be the current and the phase angle between the current and voltage? So current is asked means that find the current. If you want you can write, or otherwise directly RMS. So IRMS is equal to ERMS by Z. So ERMS is 200 and Z is going to be 12 square plus this is going to be 16 square. Allava? 400 100 அதுக்கு ரூட் 20 10 வருமாப்பா 10 ஆம்பியர் தானே IRMS. Okay, phase difference between current and voltage, tan phi is equal to what? R by Z. So 12 by Z எவ்வளோ 20. Okay, so phi is equal to tan inverse of 6 by 10. Okay, right. Okay, question number iduvaraiku. Okay, are you all comfortable? Any doubt pa? Anyone you did not understand, should I explain again? Tan phi எப்படி R by Z, cos phi தான் cos phi தானேப்பா. எப்படி இப்படி R, this is going to be Z, this is phi. So cos phi is R by Z. So இது வந்து cos. Okay, okay, next question, question number 12. LCR circuit, 240 watts, 240 volts. What is the resonant frequency? That is the first question. What is the resonant frequency in that question? Okay, so again another LCR circuit, question number 12. LCR circuit, need not draw the diagram also, directly we can do, just I am writing for your sake. Okay, so here L is given. If they have given Henry, this is nothing but the value of L. 80 microfarad capacitance is also given. Resistance is given as how much? 40 ohm. Here this source is 240 volt and okay, frequency is not given. Okay, so we don't need any diagram itself. Frequency, if we need to know, omega R is what they have asked. That is nothing but 1 by root LC. Resonant frequency is nothing but 1 by root LC. So 1 by root of what is L? 5. What is C? 80 into 10 raised to minus 6. Okay, enna varum papas and puppies? 1 by 20 into 10 raised to minus 3 varudhu illaya. Okay, so this is going to be okay, 50 radians per second varudha. 50 radians per second. Okay, so what is the current at frequency, resonant frequency? What is the current value at resonant frequency? Maximum peak. So need not consider this capacitor or inductor values then. So that time simply ERMS by R. So the current at resonant frequency is nothing but ERMS divided by what? R. So what is ERMS? 240. What is R? 40. Okay, 6 ampere. Done. Okay. What is the voltage across capacitor at resonance? That is the next question. How much? net effect will be 0. Inductor ഇവർക്കിടയിലെ പോർട്ടിൽ they will be 0. Otherwise just check. 240 നോക്കട്ടെ. So voltage across the capacitance at resonant frequency will be what? The current at the RMS value of current at frequency. Voltage, next question is voltage across the capacitance at a resonant frequency. So that will be nothing but the current at a resonant frequency. Which current? RMS value of current at a resonant frequency into divide by XC. Okay, so this is nothing but into XC. Okay, so this into XC. How much we got? By nothing but 1 by omega C. 1 by omega C. So how much is omega? Rate resonant frequency 50 into 10 raised to minus. How much we are getting from this? That will be the answer. Correct or what? So how much will be getting? volt, 1500 volt. So how much will be the voltage at inductor then at resonant frequency? How much will be the voltage along the inductor at resonant frequency? Same and opposite. Maybe 1500 minus 1 by 1500. So both of them putting together, this will be cancelled off. Clear? Okay, any confusion so far?
Sir.
Resonance frequency I maximum. I maximum.
Not that one. See, in resonant frequency also we will have I maximum and what? I RMS, everything will be there. But at a resonant frequency means we had instantaneous current, maximum current, RMS current when we connected resistance alone, right? Do you remember? Same kind of situation will come. But inductor, capacitor, everyone will be there, but their effect will be nullified. Okay, so maximum current we get means that doesn't mean that is the maximum current, that is the IRMS. It is not like that. The maximum current and RMS current, everything will be maximum at a resonant frequency. So at a resonant frequency also we will have maximum current, RMS current, everything. It is just like a resistance alone. That's it. Okay, clear? So it's time for break. Is it? No? 10 minutes. Now we will continue. So next question number 13. Yeah. So a resistor of resistance 400 ohm, capacitive reactance 200 ohm are connected in series to a 220 volt 50 hertz AC source. If the current in the circuit is 0.49 ampere, find the voltage across resistor and capacitor. Okay, how much? So current is given in this question. Current is given as question number 13. Current is given as 0.49 0.49. What current is this? What is this? RMS current. What they are asking? Voltage across resistance. Voltage across resistance means what they are asking? RMS itself. They are asking what? RMS. So this is nothing but IRMS into R. 0.49 into resistance is given or what? 400. So whatever we are getting, that is the RMS voltage across the resistance. Clear? Another question what they have asked is, what is the value across VR across capacitor, right? Okay, VC RMS, that is the RMS voltage across capacitor. So this is going to be what? IRMS into capacitive reactance. IRMS into capacitive reactance, which is nothing but 0.49 into capacitive reactance is given again 200. Yes, so this is going to be 98 volt. Okay, now what they are asking is, what should be the value of inductance? What should be the value of inductance so that voltage and current are in phase? Voltage and current should be in phase means what should happen? XL should nullify XC. So what should happen there? XL should be equal to XC. That's it. Done. So if that is, so this is first question, this is second question. Third question, what they are asking, V and I are in phase. V and I are in phase. So this is nothing but XL must be equal to XC. XL must be equal to XC. Okay, so what is XC? XC is given as 200 and we need to find what? This inductor. We need to find the inductor. So L value is nothing but 200 divided by 2 into pi into how much is the frequency? 50 hertz. Okay, so 50 hertz. Put whatever answer we are getting, that is the 64 Henry. Correct or what? Correct? Okay. Next question, question number 14. A radio wave of wavelength 300 meter can be transmitted by a transmission center. Okay. A condenser of capacity. Condenser means what? Capacitor itself. A condenser of capacity 2.4 microfarad is available. Calculate the inductance of the required coil for resonance. So here, number 14, wavelength of radio wave is given 300 meters. Okay, a condenser. So what we need to do? We need to find the inductance at a resonance. So obviously what should happen? XL must be equal to XC. So here 2 pi F into L is equal to 1 by 2 pi FC. Okay, suppose if we need to find inductance, this is nothing but 1 by 4 pi square F square C. Correct or what? Now what all things are given? 4 pi C, everything we know. Frequency is given? No. So that we can find from here. Correct or what? Okay, so find what is the frequency we are getting. Okay. C is equal to nu lambda, we have studied, no? C is equal to nu lambda, same. So C is equal to nu lambda. So nu is the frequency. So the frequency is equal to C by lambda 3 into 10 raised to 8 divided by 300. So this is going to be 10 raised to 6. So 1 by 4 pi square 10 raised to 6 square into C is given as 24 microfarad. So 2.4. So 2.4 into 10 raised to minus 6. Clear? So we need to simplify this. So somewhere around 10 raised to 8 Henry will be getting. Okay. Just look at the power of the, just do a rough calculation and take the power. Most of the time options will have 10 raised to 8, then 10 raised to 4, 10 raised to 20, like that. At least there should be that difference. Clear or what? Another question, 15th question. Over so far, okay, fine. Jayashree, a resistor of 200 ohm and capacitive reactance of 212 ohm gives an impedance of 291.5 ohm when connected in series to a source of 220 volt 50 hertz. So calculate I, VR, VC. Okay. Okay, so here, okay, fine, just fine. So is it difficult? Direct question, right? So can you do it later? Okay. Shall we move to the next question? Okay, let us see an LCR series circuit with L is equal to 100 millihenry, capacitance is equal to 100 microfarad, resistance is equal to 120 ohm is connected to an AC source of E is equal to 30 sine 100 T. Okay, find the impedance, peak current and resonant frequency. Is there anything there? Is there difficult? Impedance root of R square plus X square, correct? So X maybe you will have to find, that is also easy, right? Impedance we can find it out. Peak current, source current is, source voltage is there, so E0 by Z, E0 by Z, correct or what? Anyone is finding difficulty? Should I do it on the board? Okay, should I do it on the board? No? Children, all of you? Okay, then resonant frequency 1 by 2 pi into root of LC. Okay, so we can do like that. So those problems in the handout is done. Again we will continue. Okay, so some simple concept like a power factor. After that certain circuits, okay, seems to be very complex, but we can do it very easily. So those things also we will discuss, then we'll wind up the session. Okay children, thank you.